Hello, today I'll be talking about breadth first search or BFS. So BFS. So in the previous video I talked about depth first search, which is another type of graph traversal algorithm. So if you haven't already, I recommend you watch that video first, as I will be mentioning concepts from depth first search in this video. So I guess to get us started, if you want to kind of imagine what BFS is, think about like dropping a petal in a pond. When you're watching it like the ripples, they kind of spread outwards, starting from the center first, and then it kind of spreads layer by layer. And that's kind of the general concept of what BFS is. It kind of explores the graph in, you could say, waves, and then for each kind of level or layering of the graph, you can traverse everything in that layer. And then you kind of repeat that until you go deeper and deeper into the graph. So let's start with a visualization. So this is very similar to the graph I used in DFS, but yeah. We'll start with this parent node, so number 1. And for the parent node, in DFS what we did was we looked at all our possibilities and then we just took one of them and then we kind of kept going down until we reached the end. But for BFS we're not going to do that. We're going to look at all of the available child nodes and we're going to go through each one before proceeding further. So then we'll go to 2 and then 3. And then once we do that, we've basically visited every single node, let's just say one step away from this parent node, or we can call it level 1, so level. And then once we've visited all these nodes, now we can go to the next level. So for each node connected to 2 and 3, we can then kind of somehow store these, which I'll get to in implementation. And then we can traverse through all of the nodes that are, let's say, 2 steps away from the parent node, or 1 step away from the node level we were just looking at. We'll call this level 2 or something, and then we can just explore all these nodes. And so this is kind of the general concept like I talked about with the Pebble. You first search at this level, and then this one, and then this one, and then you might have more going on here, and then so on and so forth. So you can see how breadth first search kind of takes on a more, I guess, breadth first approach to traversing a graph, where you kind of just find everything in the area, whereas depth first search, you go really in deep into one pathway and then you traverse back out and then you just continue that over and over again. So BFS, you don't have to go backwards or anything. You'll kind of just keep descending lower and lower and lower. And yeah, that's basically the whole idea of breadth first search. So if we kind of think of this in a more programming related idea, let's say we have the same graph, but this time we'll keep track of something a little bit different. So this time we will actually just, for each node, we'll kind of simulate what how BFS actually runs in your code. So let's just say we have this parent node. So at 1, I'll just label all these 1, 2, 7. So we have 7 nodes. At node 1, we're going to check we'll have this stored somehow, but we'll check every connected node to 1. So we see we have 2 and 3. So at kind of the parent node, there's only one node, so we don't have to worry about it. We just have these 2 nodes that we can check in the next one. So we're done with level 1. We're going to go to level 2. So let me actually kind of reorder this. So I'll just call it level 1. We have 2 and 3. And so for level 2, for this node right here, 2, we have 4 and 5. So 2 is connected to 4 and 5. And then for 3, we have 6 and 7. So 6 and 7. So for level 2, we have 4, 5, 6, and 7. And basically what we're doing is that for each node in the level, which we get from the previous level, we basically loop through, or we find all the connected nodes of each node in this level. So in this case, the nodes in this level are 2 and 3, so we find all the connected nodes to 2 and 3, which are 4, 5, 6, and 7. And then we can store these nodes so that for when we go to level 3, all we have to do is access what we have here, and then we can basically repeat the process. So I'll just do like a few more. Let's say it's 8 and 9, and then 10, and then so on. So level 3 we have 4, which is 8 and 9. We have 5 is empty. I'll just say that. 6 has 10, and 7 has nothing. So now we have 8, 9, and 10. So this will be for level 4, and you can see this process just keeps going over and over again. And yeah, so hopefully that kind of visualizes how BFS works, where for each level we just find all the connected nodes. We store that somehow so that in the next level we can, or layer, or however you want to call it, we can do another recursive call again. And yeah, so what are some key properties about this type of graph traversal? Well, one, it always finds the shortest path in terms of like the number of edges, which are what you call like what connects pathways between 2 nodes. You can always find the shortest path in terms of the number of edges. So let's say I want to get to node 10, or sorry, let's just do node 6. So that's right here. Let me actually delete some of this. So if we were to use depth first search, what would happen? Well, we'd have to go from here, then down to here, then down to here, and so on until we reach end. We have to come back up and then check here, then check here, then go here, and then we reach level 6. So you see how it's not really efficient when we could have just, let's say, gone to just this level. We could just end it here because the node we're looking for is only on the 3rd level. So what breadth first search does is it first looks at this level, and then it looks at this level, so 2 and 3, 6 is not present, and then it searches here, and obviously 6 is present, so yep, we found it, and we've only had to iterate through 3 levels and search at most 7 nodes. And so this is why BFS is much better in terms of finding the minimum value, or the minimum distance, or I guess pathway to a node you're looking for, in comparison to depth first search. And additionally, as you can tell, you can like naturally group nodes by their distance from the start. So when we look at 6, we automatically know that it's 1, 2, and 3 units or edges or sorry, it would be 2 edges, but you can kind of determine the distance based on the number of levels it's in. So here, let's say each node is 10 meters apart in some real world application, then you automatically know you have to travel 20 meters. And so that's where breadth first search is very common or useful. And so common applications include shortest path problems. You can do social networks, web crawling, and other, I guess, fundamental aspects to anything. And it's very useful in USCO and competitive program. And yeah, that's it for this video. Thank you for watching.